in a different way, so you don't have to worry about being on the recording. And we'll show you a little bit about today's experiment and just a couple of the little reminders of what we're going to be doing. So first off today is projectile motion, projectile energy. And so don't forget to pin me so that you can see the screen zoomed in. You should be able to see all the numbers and everything in Excel really well. All right, so let's go ahead and fade over to Excel for a second. And thinking back, we had projectile motion. And the first part is we got to see if we can remember what our worksheet is. I know we think we can remember everything, but when we're looking at our data, do we remember everything? Just for example, right here, the instructions last time didn't tell us to put in titles on this graph. But when I looked back at it, I had to click on the graph to make sure I remembered where the data came from. And so then I edited the graph to make sure I understood it. Looking at a couple of the other graphs, did you include titles on everything? Did you include units? This one right here I forgot to round down. And then in the X position as well. What were your main results? Can you find your results really easy? One little note right here. What I did to help me understand is, even though once again it didn't ask me to do this, what I did is I put the model equation right down here next to the results box so that I could just really quickly and easily remember which term is connected to which. And so right here I can see pretty easily that the acceleration is A3, or really more like acceleration is 1/2 A3. So after you take a look at your worksheet, you're going to make a couple copies of different tabs, and you're going to find the velocities. Let's just make a copy of this tab really quick so that to remind you how to find the velocity. So I'm going to move or copy, click a checkbox, and click OK. Most of these steps are the same on Apple. I'll show you one small difference on Apple when we get to the end. So let's go ahead over to here. I'm going to rename. We'll name it. This time I'll just name it VX. Last time I named it something else. So to do the derivative is how we're going to find the velocity. And so just as a reminder how to do that, you're going to do one cell after minus one cell before quantity divided by the quantity of one cell after in time minus one cell after in minus one cell before in time. And when you do that, and don't forget to notice the instructions and right here shows that, yeah, you're taking this last column, or sorry, you're taking the units and you're like, well, that doesn't work out. But the reason that we're doing it that way is to remind you that you have to subtract the top row and you have to subtract the bottom row. So then you're going to copy that column, Control or Command C, and then you're going to right click or Control click in either 1, 2, 3 clipboard or value paste. After you do that, you're just going to go ahead and clear the contents of this cell, and now we got our X velocity. Then you're going to highlight the top row, click delete shift cells up, and then you got to do the same thing to the bottom one. You could either, this time because it's on the bottom, I can just click clear contents. After you do that, you're just going to go ahead and fit it. Now the X, we know that there's no significant forces in the X direction, and so you can just check that not only the X squared term, but then the X coefficient. Click on Perform Regression. And then as usual, we're going to Control C, copy the standard deviation of the residuals down the Y error column. And now our residuals look good, and our results look good. And then on this particular one, we don't have anything to compare it to, because this is just our average velocity, and we never really knew what our average velocity was in the X. Okay, you're going to do the same thing in the Z, and for the Z, you have to have a sloped line. And what is the slope of that line? Well, it's going to be 9.804 in Holland, Michigan. And so you can do a Z-score and compare it. Mine got a little bit better, in part because when you take the derivative of your data, the standard deviation of the residuals gets bigger, and so your standard error also gets bigger. And so my Z-score came out really well. The next thing it asks you to do is make a new worksheet and copy over different pieces. So here's that worksheet right here, and there's lots of columns, but these columns are just to help you calculate your energies and then finally your total energy. And so the first thing it had you do is copy over, or it asks you to do, is copy over data from the Z, and then a couple columns from X velocity, and that's so that we can get kinetic energy. And as a reminder, kinetic energy is 1/2 mass times velocity squared. But in this case, we have two different velocities that are orthogonal to each other, and so we have to take basically the Pythagorean theorem. We take the velocity in Z squared plus the velocity in X squared, and typically we take a square root of that, but once we put those two things into the kinetic energy formula, we would square those two things, and so the square root and the squared cancel out. The kinetic energy, the error in the kinetic energy is a little bit tricky of a formula, and if you want to understand how to derive it, let's say you've taken multi-1 or multi-2, you could probably derive it on your own, but if you haven't and you want to see the steps, you can go to Appendix B. There's a lot of these problems worked out, how to find the error in different formulas. And here, assuming that mass doesn't have any error, it's just equals to the mass times the square root of, here's a little trick right here to keep these in order. So the square root of Z squared times the error in Z squared plus the X squared times the Y error, the error squared. And if there was a Z direction, you could actually add in the Z, the Y, you could actually add in the Y squared, the Y velocity squared, plus the error in the Y velocity squared. Now there's a little note right here. When you're looking for the potential energy in gravity, it's just mgh. And so h comes from the Z position. And notice right here my time index comes from the Z ref. The time index comes from the Z ref, 0.033. But when we go over to the Z position, we actually had a 0 and a 0. And so there's this little step in there to say, don't forget, after you copy these columns over and paste them right here, don't forget to delete the top row and the bottom row. And the reason for that is we need to have the same time index, the same moment in time for our kinetic energy and our potential energy due to gravity. If we don't have the same moment in time, we can't add the two energies. Let's say we have one event over here that happened at some time yesterday and one event over here that happened sometime today, and we tried to add those two energies. It just doesn't work. We have to add the two energies with the same time or the same time index. And so to do that, we have to make sure our times line up. Finally, total energy is just simply the sum of those and the error in total energy. Now we're going to take one of our fitting worksheets and we're going to fit total energy. And so we're just going to copy these over into another worksheet. And here's what the end graph will look like. It has three of them, 3 sets of data, but I'm going to go ahead and delete these 2 sets of data right now. So let's click on that, delete this one, click on this set, and delete that one. And when you first fit this data, it's going to look a little bit weird. The error bars are really big and small and then really big again, and that's okay. And when the error bars are different, we can't copy the standard deviation of the residuals over. So in this case, it calculates it for us, but we can't just Control C and then Control V over here. We have to use our weighted error bars, our error bars that are different in size. Now to add data to this graph, it's a little bit tricky and a little bit different. You have to double click on this chart right here. Now you have to right click and select data, or control click and select data. And then this little fit window will come up. We have to add in a chart, and I'll show you it looks a little bit different in Apple, but I'll show you that in just a minute. And so we come down here, we can name it, let's say I want to add in kinetic energy, and we have to come down here to this range and we click over to our energy tab. Now the X values are going to be the same X values, so the same time values, and our Y values is going to be the energy values. So let's go over to energies, and we're going to just select the time column, and we just drag it down, and then we click over in this one, and Excel likes to automatically populate a cell, and so the best way I found when you're adding in series is you just simply delete it. You simply delete what Excel puts in there, and sometimes it's a little equals squiggly bracket ones. Whatever it is, just go ahead and delete it. And then I'm going to come over here to my kinetic energy and add that in. And so go ahead and hit OK, and now we've added that in. I'm going to go ahead and not add the other one right at the moment, and show you how to add error bars. In Windows, it's pretty easy. You select the data, but sometimes you don't know if you've selected the right data, and so you can come over here and hit this little drop down arrow and then make sure, yep, my kinetic energy is selected. The next thing you're going to do is you're going to come over to Add Chart Element, Error Bars, and right now it doesn't want to give me the option of more error bar options, and so just start out with a percentage. Just start out with a percentage, and there we go, and now it's added vertical and horizontal error bars. And so to make sure we delete the right one, we'd come down over here to Series Option, and let's see, it didn't actually add in. There we go. Somehow it didn't show up the first time. So kinetic energy X error bars, kinetic energy Y error bars. We select the kinetic energy X error bars and just delete it. And then come down here and select the kinetic energy Y error bars. Now we have to change the Y error bars to the right size. So we hit on the 3 bars and scroll down to the very bottom, and I'm just right over the screen. We hit custom value, and this time we can't do a fixed value. We got to change the top and the bottom. So we do specify value. And here's the squiggly brackets, and so we delete what Microsoft puts in there and go over to our energies, and we find our error in our kinetic energy, and we select that for the top. And we come down here and delete this one and go over to the same column and select our error bar for the bottom and click OK. Now it's a little bit small, but you can probably see that the error bars are a little bit bigger at the beginning, they get smaller in the middle, and then they get a little bit bigger at the end. All right, let's go ahead and shift over to Mac, and so you can see a small difference over there. Let's see, there's my mouse. Okay, here's Mac. All right, so here's the Mac, and here's the columns again, and I'm going to go over to the total energy fit. Let's go ahead and drag this over, and this time I'm going to delete the potential energy due to gravity error bars. So I'm just going to go ahead and delete those, and now I'm going to add them in. I'm just going to go ahead and start out by double clicking the graph so that I have this little side menu. But to add data, you have to right click or control click, and then you hit select data. Select data. Now if this is what the little add window looks like, and to add an additional piece of data, you would click down here, this little plus. There's one little instruction about editing the data that was there before. Before this said data, and you just come over here to the side and change it to total energy and then fit of total energy. But now to add in that potential energy due to gravity, I'm just going to come over there and click the plus, UG. Now the X values have to be the same time values, and so to find them, I click over here in this little side icon and come over here to energies, and I'm going to click on the same time index. Okay, and click that little tab again. Now for the Y values, once again, delete what's in there and come over here and click that, and it says it must contain at least one value. A little warning, but that's okay. Come over here and we find our potential energy due to gravity column right here. Okay, and hit OK, hit OK. Now it's added in those little points, and at first they're really big points. Just as a reminder how to change them, you'd click on the 3 bars, and let's see, it didn't actually select the data, so that's good to remind you how to select the data. So when you're here, you'd click on Format, and you'd come over here, and it looks like it selected the right error, but Series Options, and you go to Paint Can, and you go to Marker, and you go to Marker Options, and you change it from size 5 to size 2 on Apple. And on Windows, you can choose size 1. To add in error bars, that little drop down menu isn't available here in this side menu. You have to go over to Format, and you have to select it from this drop down menu. And then once it's selected, you can go to Chart Design and Add Chart Element. Error bars, and the more error bar options isn't available right now again, so you hit percentage. Microsoft doesn't think you understand how to calculate error bars, but we can calculate them. And so now there's the error bars, and it added the horizontal and the vertical. So to delete the horizontal, you go back over here to the Format, and you select that exact one, the X error bars, and you just hit delete. Let's see, did that delete them? Alright, that didn't actually delete them, so let's go down here, go back to select them, and the delete button's not working. Oh well, we'll deal with that in just a second. We need to change the size of the error bars. So to change the size, you select the Y error bars, and then you go to the 3 bars, scroll to the bottom, Custom, specify values, and now we can delete what Microsoft puts in that little cell. Go over to total energy. This time it's potential energy due to gravity error bars, and so we select them. Now if you look at these error bars, you're going to notice they're all the same. And so what you could technically do is you could just select the top cell, but when the error bars vary, you have to select the whole column so that each index is associated with that error bar. So here, this time I'm just going to go Control or Command C, highlight this bottom, delete what's in there, and then Command V. And it didn't work, so I'm just going to go ahead and select that column again and click OK. And then the proper error bars vertically are there. I'm going to click on the horizontal, and this time it let me delete them. And that's basically it. Don't forget to add in the title, the chart title, the axis titles. There's a couple spots that you can calculate a z-score. On this fit page is one of them. This right here is the total energy fit, the fit of the total energy. And our expected total energy is 0 because we don't expect to see energy loss. And so you can do a z-score calculation on this one. And that's basically it for today. Are there any questions before we get started? Doesn't look like there's any questions, so I'm going to go ahead and stop.